All right, so today we're going to do section 5.1. 5.1 is really expanding upon the factoring that you already know, and it's just to solve an equation by factoring, you basically just set each factor to 0 to get the answers. So just to show you a few examples, these first few are ones that are already factored for you because they already have the parentheses there. So basically, it uses this 0 number that if I have a product of two things equal to 0, the only way that can equal 0 is either A equals 0 or B equals 0, or they both equal 0. So setting the factors of something to 0 will tell you where it's 0. So if I want to solve something like this is basically x plus 2 times x minus 3. So for this to be 0, either x plus 2 has to equal 0, or x minus 3 has to equal 0. So if I solve for x, if I subtract 2 here, I'd get x equals negative 2. And if I add 3 here, I get x equals 3. And so those would be what we call the solutions or the zeros to that equation. All right, so when I have something like this, 5 is considered a factor, but 5 does not equal 0. I mean, there's no way you can set 5 equal to 0, right? It's just not possible, so we ignore it. But if 2x plus 3 equals 0, we can solve that. So 2x, move the 3 over, so it becomes a negative 3. Divide by 2, so x would be negative 3 halves. Okay, something I feel like I should tell you about. If this were a 5x out front, let's say I had something like this, 5x times x minus 2 equals 0. When you have just an x out front, that does have a solution. So think about it. If 5x equals 0, if you divide by 5, you're going to get x is 0. And of course, this one will lead you to x minus 2 equals 0, so x equals 2. So be aware when you have any kind of like x squared, out front, you're going to get x equals 0 as the solution. All right, so same thing here. You're going to set each of these factors equal to 0. So 2x plus 1 equals 0, or 3x minus 1 equals 0. And we just solve for x. So you move the 1 over, minus 1. So I get 2x equals negative 1, or x is negative 1/2. And here, if I move the negative 1 over, it becomes a positive 1. Divide by 3, so I get x equals 1/3. Okay, so those are my solutions. All right, so to solve by factoring, the first equation has to be factorable. And then basically all we have to do is factor it and then set each factor to 0 and solve it. All right, so it's just one little extra step. So we're going to go back to our factoring methods. You know, and if you struggle with this on the test, you do want to go back over it because it is important. You'll see it in Math 1325 quite a bit. And on your final. Okay, so let me get a different color ink. All right, so remember to factor these three termers. We're going to multiply the first and the last. So 2 times negative 5 is negative 10. And I need factors of negative 10 that add to 9. So I go, okay, it's not 2 and 5, but what about 10 and 1? Yeah. I could make this one negative, so I'd be 10 minus 1 is 9, and that's multiplied as negative 10. So with kill the common factor, you take the first 2 and you copy it to the fronts. Copy the factors. Then we kill the common factor. So this first set I can take out a 2. So it becomes x plus 5. The other set I can't take anything out of, so I leave it alone. So I'm factored. Now to find the solutions, just set each factor equal to 0. So this is going to yield x equals negative 5. And here, if I add the 1 over, I get 2x equals 1. So x equals 1/2. Okay. All right, so anything higher than x squared, I'm thinking I'm going to have to pull out a common factor. I should always check for that, right, whenever I factor. So like I see an x and an x and an x, so I can pull out the lowest power of x. I can pull out an x. So what I pull out, I divide by. So I'm left with x squared minus 3x minus 10. So now the quadratic that's left on the inside of the parentheses, I can factor. I need factors of negative 10 that add to negative 3. And my choices are 2 and 5 or 10 and 1. So 2 and 5 looks pretty good to me. All right, let's see. So I'm going to make the 5 negative and the 2 positive. And so this becomes x minus 5, x plus 2. So now I have 3 factors. I have this one here is just x, so I set that equal to 0. Well, I get x equals 0. If x minus 5 equals 0, you're going to add 5 over, so you get x equals 5. And if x plus 2 equals 0, you're going to subtract 2, right? And you'll get x equals negative 2. So this has 3 zeros, or 3 places where it crosses the x-axis, okay? Now, you can verify this on a graphing calculator just to show you what we're looking at from a graphing calculator standpoint. So let me pull that up for you. You can always find zeros on a graphing calculator, so I want to make sure that you can do that and just kind of look at a graph and you can verify your results here. So I'm going to pull up TI. Here we go. Try and pull it up. Let's try it that way. Well, maybe we'll pull it up. I'm hoping it's coming up. All right, well, sometimes we go to a second app. Let's see. I don't have it installed on this computer. Let me try one more time for TI Smart View. Whoa. Okay, my TI Smart View is struggling with loading right now. It's still working on it. Let me see if I can, if we're even still recording, I don't know. Let me pause. Okay, after some technical difficulties, I've got my TI here, so you can always find zeros on the calculator, and you can verify this by factoring. So just to show, I'm going to type in this equation here. So x cubed minus 3x squared, so this is the x button, x arrow cubed, arrow out of that, minus 3x squared minus 10x. And one thing you can do pretty readily, there's several ways to find zeros, but one is to just type in the right-hand side, which is 0, into the calculator. Go ahead and graph it. I'm going to hit zoom 6. And you can see that curve crosses the x-axis at -2, 0, and 1, 2, 3, and 5. So those were the 3 solutions I got. You can verify those when they're decimal solutions by finding the intersections. So the way that I do that, I mean, I can pretty much see them, but just to show you how to do that, you do second trace or second calc. I want number 5 intersect. it'll find the zero it's closest to. So it should find the one right here at 0. So first curve, press enter. Second curve, enter. Third curve, enter. So 3 enters. The intersection's at 0, 0. So if I want to go find the other one, I'm going to move the curve. Well, let me do second trace intersect. Second trace 5. Now let's say I want to find the one down here. So before I do anything, I move the cursor using my left arrow button so that we're down toward that one. Now I press enter 3 times. And there it is, -2. All right, and I go back up and find 5 by doing second trace intersect. Move the cursor up so that it's closer to 5 than any of the other zeros. Probably, this tells you where I am, by the way, I'm at 6. Can we go down a little bit? Just so I can see the cursor. There we go. So press enter 3 times and your intersection. All right, so your calculator can find zeros. You can verify all your factoring work here when you're solving. Okay. Now let's clear that out. All right, so let's work some more. All right, so we have a couple of factors. So now when I have 2 terms, I'm looking for a difference of squares. It's not because, you know, you have another x there. But remember, when you factor, the first thing you must always do is take out the common factor, and most definitely there's a common factor here. When I look at this expression and see x is a common factor, so I'm going to go ahead and take it out. What you want to divide by it, so you get x minus 6 equals 0. So now that it is factored, you set each factor equal to 0. So x equals 0 from the first factor, and x minus 6 equals 0. If I add 6, I get x equals 6. All right, so now I need factors of 4. So we're going to factor this guy. Factors of 4 that add to 5 would be 4 and 1. Is that right? Yep, 4 plus 1 is 5. So remember, kill the common factor. Go ahead and copy the 2 to the front, from the front, right? This term always gets copied. And then we're going to put plus 4 plus 1. And we got to kill the common factor. So we're going to divide this guy by 2. And so x plus 2. The second guy's got no common factor, so we leave him alone. All right, so now we're factored, and we just set each factor to 0. So either x plus 2 equals 0, or 2x plus 1 equals 0. So if I move the 2 over, minus 2, I get x equals -2. 0 minus 2 is -2. Here, if I move the 1 over, I have 2x equals -1. Divide by 2, x is -1/2. Okay, so -2 and -1/2 would be the zeros of the solutions to that. All right, so the next thing we're going to talk about today is solving a quadratic inequality. Okay, so to solve an inequality, all it is it's going to have a greater than or less than 0 on it attached to it. So the first thing we have to do is find the place where it equals 0. I can do this by factoring. Today we'll do it by factoring, but you can also use the calculator, and we'll get to some other options. So in between the places where it equals 0, see right here, like if you look at this graph at -2 and -3 equals 0. Well, to the left of -2, it's going to be entirely positive or entirely negative. In between -2 and 3, it's going to be either entirely positive or negative. And bigger than 3, it's going to be positive or negative because it only crosses the x-axis at -2 and 3. So our goal is to figure out where it's greater than 0, where it's positive, that means above the x-axis. All right, and greater than, the alligator opens the bigger number, so 0 is a little number. And then less than 0, 0 is the bigger number, so this would be where it's below the x-axis. Okay, You can pick test points, and we'll talk about that. You really, and we'll do a little what they call sign chart. Okay, so we're going to go ahead and solve an inequality. All right, so the way that we do that, first of all, we factor it. We're going to pretend we factored it. Yay, we got x plus 2, x minus 3, and we factored it. So if I set it equal to 0, either x plus 2 equals 0 or x minus 3 equals 0. So you get solutions of negative 2 and 3. So this is where the graph is going to cross the x-axis. All right. So really what they do is you don't need to draw this per se. You could if you wanted to, but you don't need to. So here's negative 2 and here's 3. So I'm going to test. There's a region here less than negative 2. There's a region here between negative 2 and 3 and a region bigger than 3. I'm going to test each one of those regions separately to see whether they're positive or negative. Okay. So what we're going to do is we're going to pick values. I make a table and I pick values in between in these regions. So I pick a number less than negative 2, and it could be any number. So I like negative 4. I pick a number between negative 2 and 3. I like 0. And a number bigger than 3 would be 4. Okay, so what I'm going to do is plug them into x plus 2, x minus 3, and see if they're positive or negative. Okay, so if I plug in negative 4, I get negative 4 plus 2. I'll do this once for, and then negative 4 minus 3. So negative 4 plus 2 is a negative number. I don't really care what the result is. Negative 4 minus 3 is a negative. And I know a negative times a negative is positive, all right? So I know if negative 4 is positive, this region, this whole region less than negative 2 is going to be above the x-axis, okay? So if I plug in 0 into this equation here, 0 plus 2 is 2. 0 minus 3 is negative 3. So 2 times negative 3 is negative 6. So because it's negative, everything in this region is going to be negative between negative 2 and 3. All right, so if I plug in 4 into the equation, 4 plus 2 is 6. 4 minus 3 is 1. I get positive 6. So this is positive. So everything bigger than 3 is going to be positive. All right. And you can also see this from the graph here. You see that they graph the graph, and anything less than negative 2, all the values here are above the x-axis, so that's positive. Here between negative 2 and 3, they're all below, so that's negative. And bigger than 3, they're all above. So again, we're back to positive everything out here. Okay. So I'm trying to solve the inequality. I haven't solved it yet. So what I'm trying to do is pick up the regions of x. I have to know this says less than, right? 0 is bigger, so it's less than 0. So where it's less than 0 is where it falls below the x-axis, right? So that would be this region where I wrote the negative. So it's from negative 2 to negative 3. So if I use interval notation, I'm only talking about x, don't care about y here. I know that x is between, I can write it as inequality, negative 2 to 3. Or using interval notation, I could do from negative 2 to 3, like so. All right. So let's take a look at another example. Negative x squared plus 4 equals 0. So we're going to have to work on factoring that. At first I thought it was a sum of squares, but it's not because of the negative. So let's kind of help ourselves out a little bit. Let's factor out a negative. So negative, if I factor out a negative, I get x squared minus 4. So that looks better, right? Because the negative changes the signs of everything. So x squared minus 4 factors x minus 2, x plus 2, right? So we know that there are zeros where each of these factors equals 0. So if x plus 2 equals 0, I get negative 2. If x minus 2 equals 0, I get 2. So these are my zeros. All right. So I want to know where this inequality is less than 0. So that means below the x-axis. And we're going to go ahead and do a sign test. So I know, let's see, I have a 0 at negative 2 and a 0 at 2. And we're going to make a little, so I've got 3 regions, right? I've got 1, 2, 3. So we're going to pick a number less than -2, any number you like. I like -10. Pick a number between -2 and 2, I like 0. And pick a number bigger than 2, I like 5. All right. So we're going to plug these into our expression. You can plug it into either the original form or the factored form. I'm going to plug it into the original form here because I think it's pretty easy to use that here. So if I plug in -10, it's going to be 100, -100 plus 4. It's going to be -96. I don't really care, but it's super negative, right? So from negative, anything less than -10's out here, it's in this region. So anything less than -2 is negative. All right, so if I plug in 0 for x, I get 0 squared plus 4 is +4. So this is positive between -2 and 2. That's my second region. And my third region, I plug 5 in there, I get -25 plus 4. That's going to be a negative number, right? I don't care what it is, but I know it's negative. All right, so I want the regions now. I want to pick the regions of x for which they are less than 0, right? Because now 0 is the biggest number. So that would be these two regions right here on my number line, this guy and this guy. So remember, this is -infinity. I'll put my infinities on there so you can write it with interval notation. All right, there's two intervals. So there's one interval here. So the first interval goes from -infinity to -2. Infinity always has a round bracket. -2, we want it strictly less than 0, not equal. So that has to be round too. Put round circles there. We put a little union in between them, and then we go from 2 to infinity. Okay, so that's, and you can verify that from the graph. You can see that outside of -2 here, it's negative, and it's below the x-axis for x greater than 2. So the equation, what I got matches the graph that I'm looking at. Oops. Let me clear this. Okay, well they did all that down there. Okay, so let's practice some problems. My suggestion to you would be to pause the video and try these on your own, these two, and then go ahead and restart the video and see if you did it right. Just my suggestion, because we need to practice. So first thing, step 1, factor. Let's see. Screen share. Boop. Okay, why won't it let me do that? All right, I think I'm sharing my screen now. All right, so the first thing we're going to do is factor. Doesn't seem like it's sharing. Hold on. Share. Oh, there we go. Okay, let's share this one. Yeah, share. All right, so if I try to factor this, okay, I need factors of -6 that add to 5, +5. So I was thinking 2 and 3, that doesn't give me -6 though, so one of them has to be negative. So let's see, 6 and 1, I'll make this one negative, right? So this would be x plus 6, x minus 1. So set x plus 6 equal to 0 and x minus 1 equal to 0. Subtract 6, you're going to get x equals -6. Add 1, you're going to get x equals 1. So these are the places where this thing equals 0. If you graph it on your calculator, you're going to see that 6, x equals 1. All right, you're going to see something like this. All right, so to do a sign test, you're going to put your zeros on your chart. So I have a 0 at -6 and a 0 at 1. And again, I got 3 regions for quadratics. I pretty much, well, most of the time I will. So let's pick a number less than -6. I like -7. Pick another number between -6 and 1. I like 0. Pick a number bigger than 1. I like 2. All right. And we're going to plug it into, I think it's going to be easier to work with a factored form. So if I plug in -7 for x into the original equation there, -7 plus 6 is -1. -7 minus 1 is -8. Negative times negative, this is going to be positive. +8. So I know outside of -6 is positive, which makes sense because, you know, my picture, this is above the x-axis. So between, let's see, if I plug 0 in there, 0 plus 6 is 6. 0 minus 1 is -1. So I'm going to get -6. So I know it's negative here in this region, which makes a lot of sense because I can see it's below the x-axis. And if I plug in 2, 2 plus 6 is 8. 2 minus 1 is 1. I get a +8. So again, I know this is positive out here. All right. So my inequality demands that I pick the area that's less than or equal to 0. All right. So that would be between -6 and 1. So I'm going to use interval notation. Now, I've been using round brackets up to this point. However, it can equal 0, so I want to use square brackets because remember, square bracket includes those points because it can equal 0, so we can include these guys. Okay, so there's my answers. Anything between -6 and 1, including -6 and 1. Okay, so if we try this next one. All right, so I need factors of -48 that add to -2. So I got to go through my factors of 48. If you have trouble, remember you can do -48 divided by x to get all the factors. So I start thinking of factors. Let's see, 4 and 12 is not going to work. I got to get bigger. So 6 goes into it. 6 and 8. 6 and 8 are 2 apart. So there we go. 6 and 8, and I want to make it a -2, so we'll make this one negative. Okay, so this will factor x plus 6, x minus 8 equals 0. So either x plus 6 equals 0 or x minus 8 equals 0. If I move the 6 over, I'm going to get -6 because I have to change sign. If I move the -8 over, I'm going to get +8. So those are my zeros. If you were to graph this on a calculator, you would see something that looked like 6, 8. You'd see something that looks, you know, something like this. Okay, so what am I thinking? Then what we're going to do is we have to figure out where it's positive. I want to know where it's greater than 0, right? 0 is a smaller number in this case, so it's greater than 0. So I pretty much tell from the graph it's going to be these guys out here, but we'll verify it with a sign test. All right, so remember, greater than 0 is above the x-axis, less than 0 is below it. But we're going to do a sign test. So on a little number line, I'm going to put the number 6 and the number 8. And we're going to test, there's 3 regions once again, so we're going to test these 3 regions. All right, so pick your favorite number less than -6. I like -7. Pick your favorite number between -6 and 8. I like 0. And your favorite number bigger than 8. I like 10. And we're going to plug it into the factored expression because I just think that's going to be easier to work with. So if I plug -7 into this guy, I get -7 plus 6. So that's going to be -1. And -7 minus 8 is -15. So I'm going to get a +15. I don't care, it's just positive. All right, so I know it's positive in this region. Pick 0. 0 plus 6 is 6. 0 minus 8 is -8. So I get -48. So it's going to be negative. So I know in here it's negative. And you see how it's switching every time? It's pretty much going to do that, except on what we call double roots, but it's going to happen. All right, so 10 plus 6 is 16. 10 minus 8 is 2. Those are both positive. 32, so it's positive. Okay, so I want to pick those regions for which is greater than 0. So I'll put negative infinity, infinity on my number line. So I want this region. I've got this one, and I've got this one. Open circle, because no equal. All right, so with brackets, or with interval notation, negative infinity to negative 6. This is an open circle union. Then we go 8 to infinity. And those would be my regions. Okay, so you'll be doing a lot of sign tests, and when you get to 1325 for calculus to figure out intervals of increase, decrease, and what they call extrema. So you'll be working with this, so you want to make sure you get that factoring and solving down. If you need help, feel free to come stop by my office hours. Not a lot of use of those, and I think some of you guys could definitely benefit. All right, so that's that example. See what else we got coming up. All right, so that's the end of the algebra section of 5.1. And I'm gonna do another video on the 1324 help, okay? All right, so that's it.